Few things in human physiology feel more frustrating than disciplined effort without visible change. Calories tracked. Workouts completed. Sugar reduced. Sleep improved. Yet the abdominal area remains stubbornly unchanged. For many individuals, this is the moment doubt begins, not just in a diet or routine, but in the body itself. Because belly fat behaves differently than fat stored elsewhere. It is more hormonally sensitive, more metabolically active, and in some cases, more resistant to release. Clinicians often notice a pattern: patients doing objectively correct things, yet seeing disproportionate fat retention around the midsection. This is rarely about laziness, and often not about willpower. Instead, it reflects something quieter: biological priorities operating beneath conscious control. The body is not designed primarily for aesthetics. It is designed for survival. When conditions signal uncertainty, whether from stress, chemistry, sleep disruption, or metabolic adaptation, the abdomen becomes one of the body's preferred storage sites. Not randomly. Strategically. There is an old observation in metabolic research. The body defends certain fat stores as if they were insurance, which raises a more revealing question. If your behavior has improved, and your discipline is real, why would the body still resist letting that fat go? Because the answer often begins with a system most people never think to blame. One that can quietly instruct the body to hold on, even in the presence of effort. And once you understand that signal, stubborn belly fat starts making biological sense. One of the most underestimated influences on abdominal fat is not diet or exercise. It is hormonal messaging. Specifically, the body's relationship with cortisol, often called the stress hormone. Cortisol is not harmful by design. In fact, it is essential for survival. It helps regulate blood pressure, stabilize energy, and sharpen alertness when the brain senses demand. The issue is not cortisol itself. It is duration. When stress becomes chronic, deadlines without recovery, fragmented sleep, constant cognitive load, cortisol stops behaving like a short-term responder and begins acting more like a background signal. And that signal tells the body something important. Resources may be needed. Preserve energy. From an evolutionary perspective, this is protective. The body cannot distinguish between modern psychological stress and ancient physical threat. Both trigger similar chemistry. Abdominal fat, particularly visceral fat, contains a higher density of cortisol receptors. This makes the midsection unusually responsive to stress biology, more likely to store, slower to release. So, even when nutrition improves and workouts remain consistent, elevated cortisol can subtly counteract fat loss signals. Not dramatically, but persistently. Many people interpret this plateau as personal failure. Physiology interprets it as caution. What makes this especially deceptive is that cortisol rarely announces itself loudly. Instead, it leaves faint fingerprints. Slight sleep disruption. Steadier cravings. Energy that feels tired but wired. Easy to normalize in modern life. Yet hormones are only part of the equation. Because even when stress is well managed, another internal mechanism can begin slowing progress, one rooted in how the body adapts to repeated calorie reduction. And it is this adaptation that often surprises even highly disciplined individuals. The human body is extraordinarily adaptive. Reduce calorie intake long enough, and it begins making quiet adjustments, not to sabotage progress, but to protect stability. Energy expenditure subtly declines. Movement becomes slightly more economical. Cells grow more conservative with how fuel is used. This process is known as metabolic adaptation, a survival mechanism refined over thousands of years when food availability was uncertain. From the body's perspective, unexplained calorie reduction raises an ancient question. Should resources be conserved? So it responds intelligently. Resting metabolic rate may decrease. Hunger hormones can rise. Even unconscious movements, small posture shifts, fidgeting, spontaneous activity often diminish without awareness. Nothing feels dramatic, but the daily energy gap narrows. And this is where abdominal fat becomes particularly resistant. Fat stored around the midsection is metabolically active, yet strategically valuable. It can be mobilized when necessary, but the body prefers not to relinquish it quickly unless conditions feel predictably safe. Researchers frequently observe that after periods of weight loss, the body attempts to establish a new equilibrium, one that is easier to sustain biologically. To the person experiencing it, this feels like a plateau. To physiology, it is recalibration. Importantly, this does not mean fat loss has stopped. It means the body is negotiating. But metabolism is only one side of the resistance story. Because where fat is stored is influenced not just by energy balance, but by the chemical signals directing nutrients once they enter the bloodstream. And few signals are more powerful in that role than the hormone managing your blood sugar every hour of the day. Especially when that signal grows slightly less responsive than it once was. Every time you eat, your body releases insulin, a hormone tasked with guiding glucose out of the bloodstream and into cells for energy. Under healthy conditions, this exchange is smooth and efficient. But over time, some cells begin responding less readily. The signal that once required only a small hormonal whisper now demands more volume. Physicians refer to this shift as insulin resistance. It develops gradually, often without obvious symptoms, yet its influence on fat storage is significant. When insulin remains elevated more frequently, the body receives a persistent message. Energy is available, store what you can. And the abdomen is one of its preferred destinations. Not because the body is malfunctioning, because it is prioritizing accessible reserves near vital organs, a pattern deeply rooted in human physiology. What makes this especially frustrating is that insulin resistance is not exclusive to overeating. Sleep restriction, prolonged inactivity, genetic predisposition, and even chronic stress can all contribute. So a person may appear disciplined externally, yet internally, nutrient traffic is being directed towards storage rather than release. This is why some clinicians look beyond calories first and examine metabolic markers instead. But hormones and metabolism still do not explain the entire picture. There is another variable shaping where fat accumulates, one written long before your first workout or diet. It does not guarantee outcomes, yet it quietly influences how your body chooses to distribute weight. Because sometimes the blueprint guiding fat storage was there from the very beginning. Not all bodies store fat the same way. Some individuals gain weight more evenly across the body. Others notice it concentrate disproportionately around the abdomen, sometimes despite comparable lifestyles. Part of this pattern is influenced by genetics. Certain gene variants affect how fat cells develop, how readily they release stored energy, and where new fat is most likely to accumulate. This does not predetermine your health, but it can shape the terrain you are working with. Clinicians often see this within families, similar waste patterns appearing across generations, independent of motivation or discipline. Age adds another layer. As the years progress, muscle mass naturally trends downward, while hormonal balance shifts. In women, the transition through menopause is frequently associated with a redistribution of fat toward the midsection. In men, gradual changes in testosterone can produce a comparable effect. None of this happens abruptly. It is a slow recalibration, subtle enough that many people attribute it simply to getting older, without realizing that internal physiology has been rewriting its storage preferences. Yet genetics are not destiny. They are influence. Think of them less as a fixed outcome and more as a starting framework that interacts continuously with sleep, movement, nutrition, and stress. Still, understanding these built-in tendencies can be unexpectedly relieving, because stubborn belly fat is often interpreted as personal failure, when in reality, it is frequently biology expressing its long-standing instructions. And once that misunderstanding lifts, a more productive question emerges. If the body has reasons for holding on, what conditions finally convince it that it is safe to let go? Because the answer is far less extreme than most people assume and far more reassuring. The body does not respond best to force. It responds to consistency signals repeated long enough that physiology no longer perceives threat or scarcity. When sleep becomes predictable, cortisol rhythms stabilize. When protein intake supports muscle, metabolic demand stays higher. When movement is frequent, not only intense workouts, but daily activity, insulin sensitivity often improves. Gradually, the internal conversation changes from preserve to available. This is why many physicians now emphasize metabolic health over aggressive dieting. Extreme restriction can amplify the very survival pathways that make abdominal fat more resistant. Stability, on the other hand, reassures the nervous system, and a reassured body becomes far less defensive. One obesity researcher summarized it with unusual clarity. Fat loss is rarely about punishment, it is about persuasion. Importantly, progress here is often quieter than people expect. Waist measurements shift millimeter by millimeter.